Alright, here we're looking at question 5. I've kind of roughly drawn the graph here of what should be on your paper. Alright, for question 5, it says the graph of a piecewise function is also discontinuous function. What's the point of discontinuity? Well, the point of discontinuity is where it jumps. Okay, so the point of discontinuity here would be 4, 2. But we're only worried about the x value, so the x value is at 2. Okay, so the x is discontinuous at 2 because there's a break in our graph. Now, for this one, is it undefined at any point? Well, to be undefined, it doesn't exist at any point. Here, when we get up to x equals, when it's getting closer and closer to 2, we're on this graph. But as soon as it gets to 2, it jumps down here, so it's continuous, but when we get here it still exists, so this would be a no. It exists everywhere. Okay, now does it pass the vertical line test? Will it cross any 2 points once? So yes, so this would be a function. Alright, let's look at question 8 here. It says this graph piecewise, is there a point of discontinuity? Yes. Okay, when x is 0, okay, this graph jumps from here to here. So x equals 0. Okay, now the question, the number 9 is it undefined? Yes, because here it doesn't exist on this graph at 0, and then this one never crosses 0. So this one is yes. It does not. There is a point of discontinuity that's undefined. All right, then for 10, does the graph pass the vertical line test? Does it cross more than once? No. So it is. So this would be a function. All right, let's look at question 11. Constant interval. Well, if we look at it, when we're talking about these intervals, we're only looking at our x values. So it's constant. It's not increasing or decreasing from 1 to 4. So from 1 to 4. Would be constant. So when x, since it's all dark, we're going to put equal to. So from 1 to 4, it's constant. Okay, then interval will increase. Now we're getting bigger and bigger and bigger till we hit there. So it's going to increase from negative infinity, okay, to we get to 1. Or we could have the negative infinity to 1, depending on the notation. Now we leave this open because it's actually equal to up here. Whichever notation is fine. Alright, and then, so this is increasing, and then we decrease from 4 to infinity. So I'm just going to go 4 to infinity. It's equal. Just go ahead and leave it open. Alright, so that's your intervals of increase, decrease, and constant. Alright, for question 12, we're solving an absolute value. 3x minus 4 is equal to 11. We're told to solve it algebraically, so we'll do 3x minus 4 is equal to 11. Well, then we have to say, well, what if it had been negative when we pulled it out? So we'll have to set it up as negative 11. So we'll add 4. So we get 3x is equal to 15. Divide both sides by 3. So x could be 5. Then we'll add 4 here. So we get 4. Okay, so we get 3x is equal to negative 7. Divide both sides by 3. X could be negative 7/3 as well. So that's how we solve algebraically. Alright, so for number 13, we're told to solve by graphing it. So we have x minus 4 is equal to 3. Now to do this, we're going to graph the x minus 4 apart. And we know that's an absolute value function, so it should give us the little V shape. So we put a point here. Now your graph goes further out, so it'll be easier to see. And then we'll just graph coming out this way, and then we'll graph coming up. Well, I'm kind of crooked here, but we'll graph coming out like this. And then what we do is whatever it's equal to, we'll draw a line across it. Alright, wherever they intersect are answers to this. So be 1, and it's hard to see on this, but it'll be easier to see on your graph. 1 and 7 would be our answers for this. Now, if you wanted to check algebraically, we just say x minus 4 is equal to 3, x minus 4 is equal to negative 3, add 4, and we get 1 here, so x is equal to 1, which is what we came up with when we did it by graphing, and then here add 4, and we get x is equal to 7. So we can solve by graphing, but to graph it, you just, again, graph the absolute value part and put the equals to part there. Alright, here we have an inequality. Now, remember, so we'll set up to solve like this, and then we'll say, what if it was negative? We'll have to reverse our inequality. So we'll go 2x plus 5 is less than negative 13. Alright, so for this, we subtract 5. Okay, so we get 2x, is less than 8. Divide both sides by 2. X is less than 4. Here we'll subtract 5. We'll get negative 18. So we get 2x is greater than negative 18. Divide both sides by 2. So we get x is greater than negative 9. Okay, so for this one, it's going to be x is less than negative 9, or x is between negative 9 and 4. Now, I'm going to use this graph to solve in a minute, but to graph this on a number line, okay, we'd have 4. Okay, it's going to be open, so it's not equal to, and we'd have negative 9 down here. It's going to be open, and then we'd end up with a graph that looks like this. Now, we could also use this to solve, and we would do it similar to the way we did with the other one, but we'd have to plot. So we'll look at that one on the next problem. Alright, now on this one we have x plus 3 is less than 4. We want to use a graph. They told us to use a graph. Now, when we're using a graph like this, we're not graphing it on a number line to come up with this. Now, we could graph it on a number line too in a second, but let's go ahead. What we'll do is we'll graph this part. So we're going to graph the absolute value part. Graph this. So it's plus 3, so that means we come over here, and we'll end up with a V-shaped look to it, coming up like this, and like that. Alright, now let's graph us a line at 4. Now it's going to be, again, it's going to be a little bit harder to see on my graph than yours, because mine doesn't go all the way out, but I'll show you how to come up with it. Wherever it intersects, okay, that's going to be our points that we have to worry about. Now what we have to decide is if it's this part, if it's underneath, or above. Okay, now the way we do that is, let's look at it. Okay, we came up with 1 as an answer. Okay, is it going to, but since it's like the other one where we have, it's a less than problem. So when we have a less than problem, it's going to be everything below these values. So it's going to be a between. So let's come up with the actual answers. Alright, so for this one, this would be negative 7, and like I said, it should show up better on yours, and this is 1. So our answer is going to be x is between negative 7 and 1. Again, we have this less than part, so that should be our answer. If we graphed our answer on a number line, it'd be negative 7, open circle, 1, open circle, and then connect it. Now, on the next video, what I'll do is I'll go ahead and solve this algebraically to show you how to do that. But again, to graph it, we take the number here, we draw a straight line across, graph this part, wherever they intersect is going to be our numbers here.